Welcome to another tutorial of the thermal system design class. So in today's tutorial, we're going to start covering a new problem, which is going to be problem number 3. And we're going to cover the flow through a pipe, and it's going to be the internal flow. So the conditions is the working fluid is going to be water, the pipe diameter is going to be 1 inch, the pipe wall temperature is going to be 25 degrees Celsius, room temperature. The inlet velocity is calculated from the Reynolds number, which is 500, which tells us that this problem is going to be a laminar flow. Our inlet water temperature is going to be 80 degrees Celsius, and we're solving for the contours of the velocity and temperature. We're going to plot the velocity, temperature, and pressure at different locations down the stream. We're going to calculate the surface heat transfer coefficient, the velocity and the thermal boundary layers, and the total heat transfer rate. In this line, we can see our geometry. We can actually create a 2D plane for the pipe, and if we look at on the in the 2D dimension, we can see that it's gonna be very similar to a rectangle. So we're gonna have a 1 inch diameter. That is gonna be the height of this rectangle, and we're gonna have a 30-inch length. And here on the bottom, we have the Reynolds equation and the velocity isolation. And we can obtain it from our Reynolds number and our conditions, our mechanical properties for the water. We can obtain the velocity for this problem. So if we go to the ANSYS interface and we click on fluid flow, we can start creating our geometry. So we open our geometry. The first thing that we do is that we click on our units. Then we are going to create a new sketch. We right click, look at, go to sketching, on draw. We'll just draw a simple rectangle. Then we'll go to dimensions. We'll click on general. And we're going to start creating the dimensions for our rectangle. So the length is going to be 30 inches and our height is going to be 1 inch. If we go back to modeling, we generate the sketch, and we go to concept, surface from sketches. It's going to ask us to select our sketch. In this case, we don't have any other part that it's going to be interacting with this, so we can just leave it as add material, and we'll just generate it. And there we have it. We have our surface for this problem. So if we close geometry and we click on meshing, and we wait for meshing to import the geometry, we're gonna have this rectangle, zoom to feet. And what we're gonna do to have a very defined mesh, we're gonna click on insert, face meshing. We're gonna select our rectangle. Now we're gonna have a structure mesh, but we're also gonna add, if we go to right click, insert, sizing, and we click on edge, we're gonna add the inlet and the flow, or the left and right edges. We apply it to element size. We're gonna go into number of divisions. We can actually we can see if we zoom here, we can see our geometry. So for number of divisions, we can actually go for 100 divisions, and we're gonna click on bias. We're gonna click on the third one, which is gonna give us a thicker meshing at the middle. So we want a more refined mesh at the edges. That's because that's what is gonna interact with our fluid. Go again to zoom to fit. We're gonna insert another sizing. In this case, we're gonna select the cylinder walls, apply. The type of sizing is gonna be number of divisions. We're gonna have 1,000 divisions, and we can generate our mesh. So if we zoom to our meshing, we can see how on the edges is more defined, and at the middle of the pipe we have a more coarser meshing. This is good for our analysis because we're trying to simulate and get the surfaces, different solutions at the surfaces of the pipe. This would allow us to have better interaction with these boundary conditions. You can actually go into sizing and you can change this bias factor. Let's say, for example, you go to 50, you're gonna have a more defined mesh at the edges and a little more coarser in the middle. So let's actually generate that. This is how it would look. It's a matter of preference in this case. We're gonna leave it as a 20. Generate it again. That's how we create our mesh. So if you close this, sometimes whenever you close your meshing and if you still have this yellow sign, you can click again on update so you can read it properly. And once this finishes and a checkmark appears, then that means that we are good to go. So now that our meshing has been updated properly, we'll go to setup and we click on it. And we'll have the Fluent launcher. We're not going to select all precision in this case. We'll keep it as a single precision problem. Go to solve. And once ANSYS has read our geometry, we can start creating our case file. So the first thing that we do is we go to general, we go to check. So we're gonna check our minimum volume and we're gonna check that it's not a negative number, which means that we're gonna actually get a solution. We can report our quality. We can see that we have a very 0.999 quality. The closer it is to 1, the more fine it is. So we have a pretty good meshing for this problem. We'll go to solver and we're gonna have for pressure base. Our velocity formulation is going to be absolute because we don't have any change of velocity, any dynamic effects, and it's going to be just a steady state problem. So if we go to model, we're going to turn on the energy equation. And if we go to viscous model, we're going to keep it as laminar. If we go now to materials, we can see that the material that is selected is going to be air. So if we create an edit, if we go to the Fluent database, we go all the way to the bottom, we can see that we have water liquid as an option. So we'll select this. Okay, so we select copy. So it's now copied to our materials. Close it. Great. Close. So let's say, for example, here you already have your water liquid and you want to delete your air. Sometimes it's not gonna allow you to do it because right now it's telling us that the surface body that we selected is actually using the air still. So we're gonna go to our cell conditions, our surface body. We're gonna click on edit and we can see that in material name we have air selected. We'll change it to water liquid. We apply it. Now we close it. And if we go back to materials and if we select air and we delete it, now it's gonna allow us to do it. So now we go to our boundary conditions. So I noticed that we actually did some error on our meshing. So we're gonna close this very quick. So we did not, on our meshing, we did not define our inlet, outlet, and our walls. So we go back to meshing. It's gonna give us this. I'm gonna select this, right click, create no name, inlet, okay. Select the other edge, right click, create a no name, outlet. I'm gonna select these two surfaces, create a name, and this is gonna be our wall. Now it's been selected, we generate it. We can close it. It's gonna ask us to update it again. So now that our problem is set up, we can go. We click yes, changing our problem again. Everything is still okay. If we click on those, go to materials, we have fluid, our liquid still selected. So it's all good. Can go back to our problem. We go to boundary conditions. Our inlet, we select our inlet and we're gonna select the velocity inlet. We're gonna edit this. It's gonna ask us for a velocity magnitude, which we already calculated using the Reynolds number. So it's 0.0197. And the inlet temperature, the inlet water temperature is gonna be 353 kelvins. We apply it and we can close this. Our outlet, we're gonna select outflow. It's gonna ask us the flow rate weight. We want 100%. We apply it, close this. Our wall. If we click on edit, it's gonna take us here. We don't wall motion. We have just a stationary wall, no slip condition. And if we go to thermal and we select on thermal conditions temperature, we can set up our room temperature, which is 298 kelvins, and we apply it. As we stated on our problem, the pi wall temperature, apply and close. Again, you can check all your numbers here when you go to reference values. Now if we go to methods, we're gonna select simple, Pressure, we'll select standard. Momentum is going to be second order. Energy is going to be second order as well. We click on controls. We see that everything is in order. On monitors, we go to residuals. This is our criteria. We're not going to change it this time. We leave it as it is. We click on initialization, hybrid. We initialize. And once the initialization is over, we can start running some iterations. We can check our case. No recommendations at this time. We'll go for 120, 100 iterations. And we start calculating. So you can see that our continuity line is going down. So that means that our solution is converging. Most likely it's going to converge on this number of iterations. It might not. Calculation is complete. Let's see. As we can see on our solution number 87, our solution has converged. So from last problems to this problem, one of the biggest difference is that we redefine our mesh to a more, our mesh was better than the other ones. So that is because of the sizing methods that we use. So something definitely to consider depending on the problem that you have. If you have a very good mesh, then your solution is gonna converge more easily. So in the next tutorials, we're gonna look at the results of this problem.